Okay, we're up in the top of the atrium again, as evidenced by the spider beam, and the room is round. This is Randy. He's carefully tapping these holes because you break a tap off in something 2 inches thick and that could be a problem. Anyway, he does a lot of things. He does steel works and ornamental iron, and runs a drill press, and loads bags of rocks and sand, and pours concrete. We haven't had him do any electrical work, but I don't know if he may can do it, I don't know. But we had him do everything else, and he's never had a problem. Oh, got Joe Mel. Joe Mel, he's the drill press operator. And yeah, he's only got 2 kids, I think. Randy's got a basketball team full. Benji's got one just past newborn, and one that's like 6 or 7 in grade school. He's bending stirrups. This stirrup bending plate is supposed to be on a stand outside. But in our poor ass soil here, my wife managed to get banana trees started, and we always could grow cassava. I think it'll grow out of concrete. It grows in drought, it grows anytime. But she's got it all crowded around the stand, and the stand is 3 feet into the ground with plates on the bottom. And the ground is hard as the devil. So we were standing up here adding some collars on this for 3 different sizes of stirrups that we don't normally make. And I said, well, why don't we just do it up here? Because the dragon gauge stirrups, they're so big. It's like we're pouring bars of concrete that you have to drive over. So it ended up that the rebar ended up looking like a rebar for a beam laid on its side. And that makes it a pretty long piece of bar to wrap around these collars here. When it's downstairs on its stand, one guy works the handle, and he just walks around the table, you know, until he gets back where he started. So we basically use 2 guys down there. One of them keeps the bar level so we don't put too much of a twist in it. Though we don't really care about that if it has some twist, you know, but we're going to take the 2 ends and tie wire them. Okay, this bending jig, it cures a couple of ills. That's 2.5 inch Schedule 80 pipe collars. We have 5 of the plates, and they have collars welded on them for things that we use for the house, for the columns and the beams and stuff. So we can make any time we want. So 5 plates is 10 sides. One of them only has something on one side, and I think this must be it. But those collars are bolted on this one, so we can take them off and still have a flat work plate. Anyway, the 2.5 inch Schedule 80 pipe is Schedule 80 because a 2 1/4 cam roller fits right in it, loose but in it. And the radius is the minimum bend radius that you're allowed to have for number 16 bars. It's a little tight. It's close to the limit on 18, number 18, or 18 millimeter they call it here. Be a 3/4 inch bar US. But if you bend them around just a bolt sticking out of a piece of wood, then they bend a lot sharper than that, and you lose maybe I don't know, 25 or 30% the strength of the whole bar. So you basically downsize the bar size just by doing that. And this is why we generally have 2 guys, but everybody's busy. It's just being ugly. Yeah, bring out a camera. That's what happens. Everything screws up. Work all day long until you get that camera out. The other thing that's that we do is we bend the the starting and ending ends of the bar 135 degrees instead of 90. That's 45 degrees past the 90-degree corner. That locks a piece of poured concrete in the center of that thing with the bars going down either side. It's for anchorage on the rebar, and you haven't got anchorage, you haven't got much. If you look at other videos, you see very few of them actually bend the ends around like this. It's code. It's Philippine code. There's a publication. I forget the word. It's something like suggestions or recommendations, but the government has printed it. And it's the way they want concrete buildings built. So they call it recommendations for RCCI buildings. Reinforced concrete with infill concrete. Reinforced concrete, RC. Anyway, it means a concrete frame with hollow blocks filling up the daylight. All the hollow blocks really do is give you a place to attach the render to, so that the masons know where the walls go. They don't do much other than that. This stirrup here, if we had to build 10 like this, it could take all day. Normally we would have 2 people, and one guy, his whole job is just to keep the thing in place, rather than trying to rely on gravity. And then we're trying to work the bender handle from just one side. See, we're supposed to be able to go around the thing, but he's having to struggle with keeping the bar where it has to be, and then figuring that which of the bearings goes in the plate, because we're only working from one side. The near side is on the outer bearing, and the far side is on the inner bearing. So that makes it fun. On the table here, this is Benji's other project, Benji's and Joe Mel. This is a circle of 5.5 feet. These bolts, they're into a piece of blue pipe, which is stuck into a piece of orange pipe. And the orange pipe matches up to holes that you can't make out. Still can't make them out. Barely visible there. There's 2 little round holes between those 2 LED lights. And when it was cast, those were pipes that stuck down about 1 inch out of the bottom of the poured concrete, because they were located in the phenolic board forms. The phenolic board forms were 4 by 8 sheets, and that's them screwed onto the top of our work table. And there's a place for where all those wires are coming out. Right between them is another one with no wires. That's the electric that goes to the motor for this whole house fan. And oh, okay. That's the that would have had an orange pipe in it if it was still up on the ceiling. So by saving these 2 pieces of plywood, and we know which side is right side up, because when you drill through from one side where you're not working both sides of the plywood, it splinters out here. So we know that what you're looking at was the bottom, and the holes are exactly located on this frame. So when we flip it over and pull it up to the ceiling, the bolts will fall right through the holes. We got a 3/4 inch hole and a 5/8 bolt. So that's sloppy loose. And I wrote line up hole. Once you take this thing off the table, any of them could almost fit. But we need to know when we're trying to put it up there, because we're going to drop the 5/8 rods, a couple of them from up above, That's 24, 32, 34 inches of concrete from this face here to the top of the upper slab. Sounds thick, but that's what it is. Yeah, that's right, that's what it is. So we're going to use up about 3 feet of bar there, and the other 7 feet will hang down. And we're just going to tighten some nuts up on the top. Just going to weld some wings on them like a T-nut or wing nut. And we'll wind that rod up through to the ceiling. And when we get this up close, we'll put the rest of the rods into it. But this bolts up there. And ran these blocks here. It's not possible to machine bearings inside of the center of a housing back to back and then have ends small enough for oil seals, and then you have to get the bearings in there. So I elected not to make a foundry pattern. I could have made a foundry pattern split into 2 halves, like a crankcase on a car and an oil pan, you know. But we decided we could get this metal, and it's 4340 for this block here and that block, and then there's a couple of them are 4140. The one he's working on is 304 stainless. Those 2 over there are 6063 aluminum. That's 316 stainless. There's the problem child. That's a piece of 5-inch stainless heavy wall pipe. And that gets welded between 2 of these flanges. Oh, he's working on the last one. This one gets 2 bearings. Can't see down there. There's a separator flange about 9/16 thick. But you get a spherical roller bearing on the upper one, and the bottom one is a Timken, fits a tractor trailer hub. Cheapest way to buy something is find a truck part, because they make millions of them. It's about 15% the price of one that's an 1/8 inch bigger or smaller. Anyway, these things all get bolted together with 10 1/2-inch bolts. It has to be line bored. We're going to do that right here on this table. And that's the fan housing. And there's these flanges here. That's a Randy and Benji product cut out of 1/2 by 3.5 flat bar, just sawed, and a Harbor Freight bandsaw. And that it's a 7/8 hole, and we're only going to put a 3/8 inch steel rod in it with 2 nuts, one on either side. The other end of those rods comes up to this thing up here. There's holes everywhere. All right, be 20 rods, and they're one set runs high, and the other set runs 8 inches below it. Every other rod. That's sort of like the way a motorcycle wheel is put together. You know, so that it can't move side to side, and it can't move up and down. So that's that project. I don't want to ruin his luck by filming another stirrup bend, because I know how that went. He started about 2 or 2.5 hours ago, an hour of lunch, so maybe 2 hours ago of work. And he's made this stack here, and there's some more down there, and there's probably a stack close to where he's working too. But he needs 114 of that model, and then 40 each of some that are 3 times as big. This is a tiny stirrup for us. It's, you can see, it's not very big. So it looks 9 by 16 maybe. And we'll take these ends here and we mash them together and put a tie wire on it. and these get put into 2 notched boards, and the notches are the spacing for the stirrups. So when you drop your stirrups on the notches and shove the rods in there, and you just tie them. There's no big thing. And we did that on the entire house. Every column, beam, whatever. They were done on a couple sawhorses out in the property and then just carried up there. And some of them took 8 people to move. But it ties together so fast. We do 6 of these really big beams in a day. Of course, that's after the stirrups are made. That's not counting the stirrups. Like he's got enough there for probably 2 beams. The stirrup spacing is another important thing in this kind of house construction. By code, the widest spacing you can put on a run of stirrups across the beam is the thinnest dimension on the rectangle of the concrete. If it's, if there's a width and a height, if the width is the thin number, that's the maximum a stirrup can be. You have to have one that close. If you have a simply supported beam, like it's sitting on posts on both ends, and all the weight is down in the middle. If you're going to cantilever it off the post, that's one thing. But if you're going to connect that beam, the rods go through to another beam or around a corner or whatever. Or if you have a post that's going to have things set on the top of it, and it's also down in the concrete 6 feet down, you double up the number of stirrups for the first 3 stirrups, but you don't have to do that out in the middle. And your splices, well, you have the top splices and the bottom splices, and the one is at 1/4 the length of the beam, and the other places you can splice them is half the length of the beam. So 1/4, 1/2, and 3/4, that's where splices go. There's nothing that says you can't take a piece of rod and leave it in there that's way too damn long, but you can't have less than around 16 inches of overlap. It's done to bar diameters. Everything on rebar is measured in bar diameters, at least everything I know about. The splicer is just one example. The inner radius curve on bends, that's done in bar diameters. There's about 6 things, and I'm just drawing a blank. But if you can download that recommended practices thing from the Philippine government. I don't care what country you're building in; it's really good information. It also has things in there that you want to read before you approve your architect's drawings. Even if you're doing it yourself, you need to look at these couple things. Window placement. The most failures from earthquakes are a twisting motion. It's like you're trying to ring the building top to bottom, like turn the top slab against the bottom slab. Sounds odd, but when you think about it, it's exactly what happens. If you have a square and the 2 walls opposite each other, one has a bunch of windows and the other one doesn't. The one that doesn't, it's got basically shear panels built in, huge shear panels. That side doesn't distort. The one with all the windows does distort. And that's why it can move compared to the one that has no windows. So they want you to balance the openings in the walls, the opposite sides having similar, airspace. There's just some really good rules. We didn't find that publication until we had this slab I'm standing on was already poured, and the bars were taking up 12 feet for this a little support structure that's, we're calling them rooms, but they're really not. But we found that we had not violated anything in that book. Nothing. We overdid a few things. I don't know how big. These columns are downsized up here compared to the first floor. Let me get a tape. Focus, focus, focus. Focus closer. Yeah, okay. 32 and 3/8. Those are like 35 downstairs. But the big difference is the depth. This looks like it's 18 inches deep. The ones downstairs are 32 by 35. So it's a little more than half as thick front to back as the downstairs. Because it only gets when it holds up. And you can tell how accurate we were when we put the spider beam on. There was phenolic board covering that entire hole. You know, just like the one down here, there was another one, another set of standoffs going up. So that that kept us from really seeing them. So this out of rotation. But that's all that column holds up, is that little bit of ceiling up there, and the spider beam with the roof on top. So it didn't need to be as big, and it's only that thick because we put all the electrical panels in the back side. Sub panels. This little cubicle we're in and the actual room down below it, they're on one panel. And there's 10 of the cubicles, so there's 10 sub panels. And that lets you put a nice heavy piece of wire over here and then really short wire runs to everything it goes to, rather than having to run either all the wires back to the mains or daisy chain a whole bunch of fixtures together back and forth with pipe and send the last one to the main. And you can't really separate circuits that way because there's only one. It's nothing wrong with that. Houses in the U.S. have been built that way for 50 years. But this takes less wire, gives you possibility of having smaller breakers and more breakers. We can isolate things pretty damn easy. And the only hard part is hooking it all up. I did 2 in this room. This one 3/4 done and the other one about 10% done. And I'm just watching construction for a month or 2 years. We're doing things we haven't done for a year. Oh, this video is way too damn long. I'm gonna shut this off and do another one someplace else.